Hello. So we're going to be solving for x when there are exponents in this video. Okay, so we're going to start off by combining the like terms that we have right now, okay? So right now we have a problem because if we look here, we have 4x squared on this side, but we have a negative 2x squared here. So what we have to do first is let's go ahead and move all our x's over to this side over here, okay? So let's go ahead and do that. So we do that by using our inverse operation, okay? So right here we have 24 minus 2x squared plus 24. Now, since we have a minus right here, then the opposite of subtraction would be addition. So we're going to add 2x squared on both sides, okay? So on this side of the equation, our x's cancel out. And on this side, it turns into 4x squared. I'm sorry, not 4x squared. It would be 4 plus 2, which is 6x squared. Just like that, okay? So now that we have our x's all on this side right here, now it's time for us to combine the like terms with 24 and 24. Now, since these are both positive, we can tell this one's positive because it has no sign right here. So since they're both positive, we're going to add 24 and 24. So 24 plus 24 is going to be 48. So let's go ahead and write that down right here. Now, at first glance, this could look a little tricky, right? Because what should we do first? Should we divide first? Should we get rid of this 6, right? Or should we get rid of the exponent first? Well, let's go ahead and try to get x by itself, okay? So we're trying to isolate x. So in this situation, what I want us to do is to go ahead and get rid of this 6, okay? So we're going to do that by dividing both sides by 6. Now, the reason we're dividing both sides by 6, if you look at the term 6x squared, when we look at that term, what we're really saying is 6 times x squared, right? So then what would be the inverse of multiplication? It would be division. That's right. So that means that when we divide both sides by 6, we get rid of our 6. And 48 divided by 6 would be 8. So we rewrite this as so. X squared equals, and then 48 divided by 6, which is 8. Okay? So now we have a little predicament here, right? So how should we get rid of this x squared? Okay, because we're trying to solve for x, not for x squared. So we're not done yet. Okay, so in order to get rid of this squared, we're going to have to take the square root. Okay, so let's go ahead and take the square root of x squared. Okay, and we are also going to have to take the square root of 8. All right, so then x squared becomes x because the radical cancels out the 2. And now we're left with x equals radical 8. All right, so now that you have x equals radical 8, that would be your answer. So then when you come over here to substitute or to check, right? If we're going to have our check, let's go ahead and plug in radical 8 instead of the x. So let's see. Our check, we're going to have 4 and not x. Whoa, what happened here? Oops. Sorry about that. Don't know what happened. But we're going to replace our x with our radical 8, okay? So it'll be radical 8, and then the part of the original equation, if you can see on this side, is the fact that it's squared. So we're going to go ahead and do that. We're going to put it in parentheses and add the squared, like how it has it in the original equation. Then we're going to put equals 24 minus 2 times, and then x again, so we're going to put radical 8 once again. Radical 8. And remember, it's part of the original equation. Right here we have it squared, so we're going to square it over here as well. And then we're going to add 24. Sorry. So then when we're solving for this equation now, this square right here and the radical are going to cancel out. So these cancel out, and now we just have 4 times 8 over here. And then we have equals 24 minus, and then again, it cancels out right here, the exponent and the radical. So then we have 2 times, and now it's just, again, plain old 8. And then we add 24, or bring down the 24. Okay. Now 4 times 8 would be 32 equals, and now we have 24 minus 2 times 8, which is 16, or negative 16 in this case. And now we have just order of operations here. Okay, so 24 minus 16 would be 8. That's right. Bring down our 24, bring down the rest of our equation over here, right? And then 8 plus 24 would be 32. So then that's how we can check if we had our right answer, okay? So this is basically how you're going to want to do these kinds of problems. Whenever you have an x squared, we're going to use the radical, right? This sign right here, in order to get rid of that, okay? So this is basically saying, if it were like a regular number and not x, right? If we had, let's say 4, right? 4 squared. 4 squared equals 4 times 4, or how we should write it, 16, okay? Now, if I were to take this 16 right here and place a radical over it, right? If I were to take that 16 and place a radical over it, what I would get would be equal to 4. Because radical 16 is telling me, hey, what number times itself, right, equals 16. We know that 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9, so the next number is 4 times 4, and that equals 16. So that's why it would be 4. So whenever we have a radical, okay, over the x, just like this right here, whenever we have a radical x like this, or I'm sorry, first, whenever we have x squared, we're saying it's x times x, right? So then when we have a radical, the reason why we use a radical to cancel out this 2 is because we're saying, hey, we know that x squared right here is x times x. So then that means if we have x squared and a little radical over it, right? The radical symbol, we're saying, hey, remember, this radical means what times what equals 16. So then right here it's saying, hey, what variable times what variable equals x squared. So what does it equal? So it would be x times x. So then that means that this right here gets rid of that 2 right there. So then you would just get x. And that's why we use a radical in order to cancel out the exponents. So then you would just get x right here. Okay, hopefully that helped. I'll go ahead and work on the other one real quick, okay? But thank you for watching.